So today we're going to look at, begin our next unit, Unit 7, going over quadratic equations and quadratic functions. So when we graph a quadratic function, the result of that graph is going to look like a U shape. In math, we call this a parabola. And on this diagram below, we're going to take a look at the different features and makeup of a parabola when it is graphed. But before I do that, I want to go ahead and look back up here at the graph, and I'm going to label the x and y axis. So just remember that your x-axis is this horizontal axis, or this axis that is going from left to right, and your vertical axis is going to be your y. First thing we're going to take a look at is the line of symmetry. It is that imaginary line that is going to cut the graph in half. So if you would flip the graph over that line, it would be mirrored onto itself. So here you can see that this dotted line or this dashed line that we have here is going to be our line of symmetry in this parabola. The next piece of the graph that we're going to look at is the vertex point. So this is the point of inflection where the graph is going to go from increasing to decreasing, or in the opposite direction from decreasing to increasing. So this is either going to be the bottom of the U or kind of the top of the U if it was flipped upside down. So in this case, looking at our graph, we can see that our vertex is located at the very bottom of this U shape. The next piece of the graph of a quadratic that we want to look at is the maximum point. So the maximum point is going to be the highest point on the graph. So this is going to be when your quadratics are upside down. So not a U, but more like a hill or a mountain. So we'll draw a picture here. So as you can see there, the maximum point would be when your parabola vertex is on top, the highest point in the graph. The minimum point would be the opposite when your parabola's vertex is the lowest point on the graph. Next, we want to look at our x and y intercepts. So the x-intercepts are going to be those places where the graph crosses the x-axis. And as you can see there on that diagram, that with our quadratic functions, in these parabolas, that we're going to have two places where the x-axis is crossed by the graph. The y-intercept is going to be where our graph crosses that vertical axis or the y-axis. So here you can see that y-intercept. The next two vocabulary terms are domain and range. So domain is going to be all the x values included in the graph. We read our domain from left to right, just as you would a book. So starting with the smallest or the lowest x value, and finishing with the greatest x value. So with that being said, let's go back up here and take a look at the x-axis. So with our x-axis, obviously, where the x-axis crosses the y-axis, that's our point of origin, where the x value would be 0. So going to right of that origin point, we're getting into the positive x values. If we would extend that out and continue on to the right, that's going to take us all the way to positive infinity. So if you can imagine, if we continue this axis or continue counting up with our x values, that would take us all the way to the direction of positive infinity, and moving the opposite direction from center or the origin, that would be your negative x values. So if you continued all the way to the left here, obviously you would continue into negative infinity. So when you start to talk about your domains and ranges, a lot of times these parabolas or these quadratics, they're going to extend kind of indefinitely in a certain direction. So you want to make sure that you're aware that off to the left would be negative infinity. for your x value. Off to the right would be positive infinity for your x value. With your range is going to be all the y values that are included in the graph, and this is going to be read from bottom to top, or from smallest to largest. Once again, just like your x values. So if you imagine the origin being the y value of 0, obviously as you go up, that's going to take you towards the y value of positive infinity if you extend it and continue to extend that. So now I'm going to put a positive infinity there at the top of my axis, and then if we extended downwards, we would be going down to negative infinity as our y value. So those are things to just kind of keep in your head. You might make a note to yourself as you start to look at these domain and ranges of the graphs in the homework assignment. So the next couple terms, increasing and decreasing intervals. This is referring to the x values where the graph is decreasing or going down from left to right, and increasing interval is referring to the x values where the graph is going up from left to right. So decreasing is going down, increasing would be going up. And we're always going to read that from left to right. So imagine just going left to right on the graph. If you're going down, that would be decreasing. Going up, that would be increasing. So let's flip it over and take a look at applying and identifying some of these terms in a couple of these examples. Starting with this first example, they're asking us to identify the following terms that are listed below. So starting with your line of symmetry, you want to look at the graph, figure out where that line of symmetry is, where you can fold that graph onto itself. So here I'm going to make a little dashed blue line where that line of symmetry would be. So here it's going to be that vertical line at the x value of -2. So remember, the equation of a vertical line would just have an x variable. So here we're going to write out our equation as just x equals -2. So that is that vertical line that would mirror the graph onto itself. The vertex point is always going to be located at the same x value as your line of symmetry. So here, let's make that vertex point on this graph. So here I'm going to do it in red over here, so you can see that vertex point, that point of inflection where the graph goes from going up to going down. So that point is located at -2, +4. Now let's take a look at our maximum point. So if our parabola is opening up downwards, right, or it looks kind of like a hill, the maximum point, or that top point, is going to be your vertex. So here our maximum point, or the highest point on the graph, is that vertex, which is located at -2, +4. And the minimum value in this case, since this graph is going to extend down and to the left and also down and to the right, this graph will not have a minimum point. Now as we look at the x-intercepts, so looking at the places where this graph crosses the x-axis, and I'm going to go ahead and label my axes here. So here we have our x-axis is the horizontal, y would be the vertical. So we're looking at where does the graph cross this horizontal axis. So here you can see we have these 2 points where the graph is going to cross, and we want to identify where those 2 points are located. So here, the point on the left there would be -4, 0. The point on the right would be located at the origin 0, 0. So let's do the same thing for our y-axis now. Let's see where the graph crosses the y-axis, where our y-intercept is located. So as you can see here, the y-intercept is also going to be located right there at the origin, 0, 0. So now let's talk about domain. So domain, if we're looking at the x values that are included in this graph, we got to understand that this quadratic function is going to extend down and to the left as we get further into our negative x values. So it's really going to go all the way to the x value of negative infinity. And since it's going to extend down into the right, remember that here we have negative infinity on the left for x values, positive infinity on the right. So this is eventually going to continue all the way to the right towards positive infinity. So here our domain. Some people would call it all real numbers, or place the symbol for all real numbers there. Or you could use the interval notation and just say that your x values are between negative infinity and positive infinity. So let's look at the range now. So remember, we're going to read the range from smallest to largest, or from the bottom up, focusing on our y values. So remember, if we continued upwards, or if it went off the graph, going towards the top of the graph, that would extend to positive infinity as the y value. If it were to extend off the graph to on the bottom of the graph, like this example, remember that's going to take us down to the y value of negative infinity. So the lowest of the y values in this case is going to be negative infinity, and we're going to read it from bottom to top. So as we go from bottom to top, we can see that the largest y value that's included in the graph is going to be the y value of 4, or the y value that's there at our vertex. So looking at our increasing intervals now, we want to look at the interval of x values where our graph is going up from left to right. So I'm going to just highlight the section of graph where our line is going up. So there you can see that I've highlighted in green kind of where that graph is going up from the left or the right. So then if we focused on just kind of the x values where that is taking place along the x-axis there, we can see that since we're going off the graph to the left, it's going to be increasing all the way from the x value of negative infinity, and it's going to continue to increase all the way from negative infinity into the x value of negative 2. So right there at negative 2, you can see that that's the x value of our point of inflection, where we go from increasing to decreasing. So I'm going to highlight the decreasing interval now. So as you can see, I've highlighted the decreasing interval in red. So if we're looking at the x values, where it is decreasing, it starts decreasing at the x value of negative 2 and continues decreasing all the way to the x value of positive infinity. So the biggest thing with our increasing and decreasing intervals, you always just want to remember you're talking about the intervals of x values. So here we're looking at the horizontal values where the graph is increasing, and the x values where our graph is decreasing. Let's look at another example. So here we have another example. I'm going to go ahead and label the x and y axis again, and also include the positive and negative infinities as far as the directions that those would be. So now let's take a look at finding the line of symmetry. So remember, the line of symmetry is that line where the graph can be mirrored onto itself. So here you see that vertical line is going to be there at the x value of negative 0.5, or the x value at the vertex. So here our line of symmetry is at x equals negative 0.5. The vertex, here, all those points are located for you. So here's the vertex. You can see that point of inflection where the graph stops going up and starts going down is negative 0.5, 3.25. The maximum point is also the vertex. Since in this case our parabola opens downward, or shaped like a hill, the minimum point is not going to apply to this parabola. Looking at your x-intercepts, where does the graph cross the x-axis or the horizontal axis? So here we can see that those 2 points there are negative 2.3030 and 1.3030. The y-intercept, or where the graph crosses the y-axis, is that 0.03. And now we get into our domain and range. So here, knowing that this is going to extend to the left and to the right as it goes down, our domain is once again going to be from negative infinity to positive infinity, or all real numbers. The range, if we're looking just at the y values that are included here, the range is going to start down at negative infinity, since our graph is going up to the bottom. Remember, range we're always doing from bottom up. Domain you're doing from left to right. So here in the range we're starting at the bottom, negative infinity, going all the way up into the highest y value. In this case is the y value at the vertex 3.25. So let's look at the increasing and decreasing intervals once again. So here you can see the increasing interval highlighted in green there, where the graph is going up from left to right, and the decreasing interval highlighted in red, where the graph is going down from left to right. So the x value is where it is increasing. You can see that the smallest x value there is negative infinity. So it's going to be decreasing from negative infinity all the way to the x value at our vertex, negative 0.5. From that point, negative 0.5, it'll begin decreasing off into the x value of positive infinity. So both those parabolas you can see are opening downwards, or make the shape of a hill or upside down U. So in that case, they're going to have maximum points, but not minimum points. And your range is always going to start down at negative infinity and then go all the way to the y value at the vertex. So let's take a look at a couple more examples where we have more of the U-shaped parabolas. So looking at number 3 to start. Let's first identify our line of symmetry, line of reflection here. So the line is going through your vertex. Once again, this line of symmetry is going to be at the x value of the vertex, or negative 0.05. So the vertex there you can see is labeled for you. That point is negative 0.5, negative 6.25. So in this case, our vertex is the point of inflection where the graph switches from going down to going up. So since we have this U shape, there is not going to be a maximum point for this graph, but there is going to be a minimum point, and that minimum point is that vertex point negative 0.5, negative 6.25. So looking at where the graph crosses the x and y axes for our x and y intercepts, let's label our x and y axis. So remember, this is horizontal axis is your x-axis, and the vertical axis is your y-axis. So our x-intercepts are negative 3, 0, and 2, 0. The y-intercept being located at 0, negative 6. So just notice that for your x-intercepts, your y value should always be 0. For your y-intercepts, your x value should always be 0. So against your domain and ranges, so remember this is going to extend off to the left and to the right as it extends upwards. So eventually it'll get to left to the x value of negative infinity and right towards the x value of positive infinity. So once again, our domain is going to be all those real numbers between negative infinity and positive infinity. Our range, remember, we're going to look at the y values included in the graphs, going from bottom to top. So the lowest y value we have here is that y value at the vertex, which was negative 6.25. It's going to go from negative 6.25 all the way off top of the graph towards the y value of positive infinity. So once again, I highlighted the increasing interval in green, the decreasing interval in red. So here you can see that the graph is going up or increasing left to right from the x value of the vertex, negative 0.5, all the way to the positive, towards the positive infinity x value. Our decrease interval is highlighted there in red. So the decrease interval is going to start towards the x value of negative infinity all the way to the x value of the vertex, negative 0.5. Let's take a look at this last example here. So look at the fourth example. I'm going to label my x and y axis. Put arrows on the ends of this parabola. So again, the line of symmetry, once again, is that vertical line there at the vertex. So in this case, we have the vertical line at positive 0.5. Our vertex is 0.5, negative 3.25. The maximum point does not apply here, but since we have this U-shaped parabola, we do have a minimum point or a lowest point on the graph. That lowest point is your vertex, 0.5, negative 3.25. Now looking at where the graph crosses the x-intercept, or that horizontal axis. So looking at the x-intercept where it crosses the x-axis, we have these 2 points. The first point being located at negative 1.3030. The second point located at positive 2.303, 0. So as you can see, where it crosses the y-axis or the vertical axis, the graph crosses there at the point 0, negative 3. Looking at our domain, once again, our domain, since it extends off to the left and to the right, if we were to zoom out or continue upwards with this graph, the graph's going to go all the numbers between negative infinity and positive infinity. The range, here the range is going to start at the y value of your vertex, which in this case is negative 3.25, extend upwards to positive infinity y value. The increasing interval in green there is going to be from the x value of 0.5 to positive infinity. The decreasing interval is going to start at the x value of negative infinity and go to the x value at your vertex, 0.5. So there's just a look at 4 different examples of graphs of quadratic functions, where we're taking a look at those different vocabulary words, the vertex, the maximum point, minimum point, x and y intercepts, domains and ranges, along with increasing and decreasing intervals.